Hi everyone. Today we're going to look at some of these problems that deal with using the Pythagorean identity for trigonometry. Okay, so before we begin, I'll just kind of do a quick review. We know that uh, every high school student knows their Pythagorean theorem, right? Pythagorean theorem, which says what? If you have a right triangle, okay, and you call the two legs of the right triangle A and B, and you call the hypotenuse C, then the Pythagorean theorem gives you this relationship, okay? A squared plus B squared equals C squared, correct? So the square of one leg plus the square of the other leg is equal to the square of the hypotenuse, okay? Now, I'm going to do this. I'm going to take the same idea and use it for our unit circle. So if you have a unit circle, say, and I'll do my best to draw a unit circle. So let's say that is a unit circle like that. We have the y-axis and we have the x-axis. Okay, and now I'm going to draw a point on the unit circle. Let's say I take this point right here. Okay, that point right there. And I label that point cosine theta, sine theta, correct? Again, that's x and that's y, right? This is x and this is y. So now if I draw that same triangle, okay, here's my hypotenuse, and I drop a perpendicular to the x-axis. It's supposed to be a perpendicular, by the way. So that is a right angle. I get myself a right triangle. Okay, so if I label the same thing, so x is cosine of x. So let me label it. Here's cosine of theta. Whoa, it's a little too thick. Okay, and this is sine theta. It's a unit circle, so the hypotenuse is 1, and I do the same thing. I'm going to get cosine squared theta plus sine squared theta. So leg squared plus the other leg squared is equal to the hypotenuse squared, right? Well, 1 squared is just 1, so I don't need the 2 there, so I could just write it without the 2, correct? I can just write it without the 2. And here is my Pythagorean identity for trig. Now, how is that going to help us to do this problem? Well, before we do it, there's one more thing you need to know. Okay. What we need to know is this. This is quadrant 1. Okay, this is quadrant 2. This is quadrant 3. And this is quadrant 4. So x-axis, y-axis. We know in quadrant 1, the x values are all positive, and the y values are also positive, correct? In quadrant 2, the x values now turn negative, and the y values are still positive though, correct? In quadrant 3, our x values are negative, and our y values are also negative, right? So any point in here is going to have negative coordinates for both. And then finally in quadrant 4, our x values are positive, but our y values are all going to be negative, correct? Any point in quadrant 1, the x and y coordinates are both positive. In quadrant 2, x coordinate is positive, but the x coordinate is negative, but the y coordinate is positive. Okay. Excuse me. In quadrant 3, our x coordinate is negative, and our y coordinate is also negative, and in quadrant 4, x is positive and y is negative. Okay? So if we know this, now we're ready to look at the problem. So let's go to the problem. Here. It says the angle theta 1 is located in quadrant 3. So in this angle, sorry, okay, so basically this angle is in Q3. So we're going to have this angle come out to here, and it's going to hit the unit circle, right? Pretend that the circle goes around this way, right? Pretend we have our unit circle that goes all the way around like that. Okay, so this is our angle theta 1. Theta 1 goes around. Here's our theta 1. Okay, and it's going to create an angle that's what I mean the third quadrant. Okay, so they give us the sine of theta 1, which is this value. They want us to find the cosine. So let's use it. Let's use cosine squared theta plus sine squared theta is equal to 1. All right, and I'm going to take negative radical 3 over 2 and replace the sine theta with it. So cosine squared theta plus, now I'm going to take this value and replace the sine. So negative radical 3 squared over 2 squared is equal to 1. So here we have cosine squared theta plus, now we're going to do the squared separately. Negative radical 3 squared is just 3, and 2 squared is 4, which is equal to 1. Okay, subtract both sides by 3/4. So we get cosine squared theta is equal to 1 minus 3/4 is 1/4. And then we're going to take the square root of both sides, right? Because the square and the square root is going to cancel out. So we're going to be left with cosine theta is equal to the square root of 1 is 1. The square root of 4 is 2. Okay, now let's go back and check. Do you remember our Q3? If you go back and check your Q3, right? Our x coordinate was negative and our y coordinate was also negative. So if we go back here to the problem, okay, cosine of theta is x. Can't be positive because in the third quadrant all your x coordinates are negative, correct? So we have to make an adjustment here. In the third quadrant, our cosine of this angle is going to give us a negative answer, and that, folks, is our final answer. Okay, that is our final answer. So let's type that in. Negative 1 divided by 2, or negative 1/2. And if we check it, that is correct. Okay, now let's do another problem. I'm going to put myself way back up there again. Okay, next problem. The angle theta 1 is located in quadrant 1, and the sine of theta 1 is 17 over 20. So before I do anything, I'm going to write my expression, right? Cosine squared theta plus sine squared theta is equal to 1. Okay? And I'm going to take my value for sine theta, which is 17 over 20, and plug it in. So I'm going to get cosine squared theta. You can call it theta 1 or you can call it theta, it doesn't matter. Okay? Plus 17 over 20 squared. We just replaced, right? We took this value and did a substitution here for sine theta. That's equal to 1. Now, we can now subtract 17 over 20 squared. So let's just quickly check. 17 squared is 289. So this is going to be 289 over 400, right? So 1 minus that gives me what? 1 minus this is, what is it, 111, correct? Yep, so over 400. Hold on, is that correct? Okay. Yep, that is correct. Okay, and then we're going to have cosine squared theta is equal to 111 over 400. So now cosine of theta is equal to, we take the square root of this. So it's a square root of 111 over, and I know the square root of 400 is what? It's 20, correct? Now we check our signs. We are in the first quadrant. Remember, in the first quadrant, everything is positive, right? Our x values were positive, our x values were positive, and our y values were positive. Cosine is x, so naturally, okay, that is going to be positive, all right? So I think we're there. Let's check. Okay, so we have the square root of 111 divided by 20, and that is correct. Okay guys, so we'll leave it at these two problems, and at a later video I'll do the other two problems, all right? Okay, great.